Namaste and welcome back to the Data Structures and Algorithms class. My dear friends, now it's time for us to deep dive and understand the concepts of time and space complexity. Now, what does time and space complexity actually mean for you as a programmer is what in a very short and simple way I want to help you understand. Let us assume the question given to us is you want to find the sum of n natural numbers, right? You want to find the sum of n natural numbers. Did you know that for the same program, there are three different approaches you can take? Approach number 1 looks something like this. Approach number 2 looks something like this. Approach number 3 looks something like this. And trust me, each of these three approaches will give you the same output, which is it will compute the sum of the first n natural numbers for you, and obviously n is decided by the user. But what if I told you that this approach takes more time for the computer to execute? This approach takes way lesser time compared to this approach for the computer to execute. And this approach takes the least amount of time compared to all three approaches for the computer. So, a very simple calculation if you do, tell me, more time means less efficiency. Less time means more efficiency. I hope you're able to think. The time taken for a program to execute and the efficiency are inversely proportional. They're inversely proportional. I hope you're able to understand. More time, less efficiency. Less time, more efficiency. So naturally, as a programmer, you must be able to have a tool with you using which you can analyze the time that a certain program that you have written will take, an estimate of the time. Because please understand, if I asked you guys to find the sum of n natural numbers for me, let us assume I asked you to find the sum of the first 7 natural numbers, then you would think and you will be like, okay, 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7, you will add it, you will total it, and you will be like, okay, this is the sum. Maybe for you to tell me it took you around 7 to 8 seconds. It took you 7 to 8 seconds. So you would say that, hey, the time complexity for me to find the sum of the first 7 natural numbers was 8 seconds. But the same thing, when you give it as a program to the computer, how do you analyze? You cannot analyze, because who's executing it is the computer. And that is why programmers and computer scientists have come up with a wonderful and unique approach to calculate the rough estimation of time that your program will take to execute. And that is called as time complexity. Naturally, when a program is executing, it will be making use of some or the other resource in your computer in terms of memory. It will take the hard disk space, it will take some RAM, etc. So don't you think space is being utilized, memory space is being utilized? Analyzing how much memory space, a rough estimate of the memory space that a program is consuming during its execution, is the concept of space complexity. So these are powerful tools with you as programmers, using which you can see whether you're writing efficient code or inefficient code. And somebody who's aiming to enter into a product-based company must always keep this in the back of their mind, that it is not about writing code, it is always about writing efficient, elegant code which takes the least amount of time and least amount of memory to perform its operation. Now that you understood why time and space complexity is required, let's begin by laying a solid foundation for understanding these concepts. Now let's begin by establishing a solid foundation, okay? See guys, these words such as big O, big omega, theta, all these words, all these notations, for the time being you don't bother about all this, you keep it aside. What I want you to do is, I want you to understand a very simple thing, which is, let us assume I have some code in front of me like this. I have some code. Guys, don't you think when the computer is executing this code, it will take some time for it to execute this code? Now I'm just going to teach you a simple method using which you can estimate how much time, if not the exact time, how much time it would take. I will give you a simple method. This method is called as the frequency count method. What is it called as? The frequency count method. Okay. What we have to do is, frequency means the number of times. The number of times each statement executes, we will first calculate first. And then we will add all those together and we will get the total number of times it is executing. Based on the total number of times, we can estimate how much time it would take. And it is going to be generic in nature. For any size input, it will work. What do you mean, you may ask? Watch it. So this is my code. Okay. I will also create one more column next to this and I will call it as frequency. I'll just call it as frequency. Great. Next what, sir? Now you must understand. Line by line I'm going. First of all, look at the first line. The first line, when it executes, I'm asking how many times will the first line execute? Obviously, it will execute only once. So the frequency is 1. And what happens when it executes is you will be creating a one-dimensional array, an integer array with 3 variables or 3 data points inside it. Cool. Next line. What am I doing in the next line? I'm calculating the length of this array and storing it inside a variable called as n. Again, how many times will it execute? Exactly once. So I'm telling 1. Okay. And if I have to show this to you, it looks like this. So I have a variable n inside which value is 3. Obviously length is 3. Now, both these statements executed exactly once, but, let me come to the next statement, which is just creating a variable called as sum. Obviously, it's going to execute only once in the program. So 1 is the frequency of that statement and the result of it is just one variable called as sum. Now, tell me, these statements, these two statements, this for statement and the statement inside the body of the for loop, will it execute only once? Clearly, anybody who knows anything about programming knows that for stands for repetition, looping. So obviously these statements are going to execute for multiple times, which means, think about it. If I am going to calculate or estimate the amount of time my code is going to take, will I bother about these statements which executes just once, or will I be worried about those statements which will execute multiple times? Anyone with common sense would tell me, sir, these statements I don't really care about, but this is the statements which will primarily decide how much time my program is going to take. This is what is going to decide whether my program is going to be fast executing or slow executing. Anyways, now one fundamental thing about analyzing the number of times a for loop works, you must understand. So let's start, okay? First time when I start with the for loop, now this line executes once. Here this initialization happens once and obviously, one time this will execute. This entire statement, let us consider it to be one statement, will execute once, right? So I'm just putting 1. And there I have I equal to 0, so I'm just showing that I equal to 0. Then I will check the condition, is I value less than n, 0 is less than 3, true. True means I will enter the loop and now this statement will execute. How many times will this statement execute? Exactly once. Right now, once it will execute. Okay, so this will calculate the sum. I'm not showing all that for you. It will calculate the sum. Next, what is going to happen is you're within a loop. Because you're within a loop, obviously, again, you'll go back to the first statement on top. And I am showing you sum is getting added here, but forget about it. Anyways, I'll just go on top back. Second time, again, you're checking the condition. So when you check the condition, you're checking if I value, obviously, first I value will increment I plus plus. I is going to become 1. I will become 1 after that, and see I'm showing the frequency. This is the second time it is executing. I is going to become 1. After it becomes 1, again check the condition. Is 1 less than 3? True. True means enter the body. In the body there is one statement. This will again execute. So this is the second time it is executing. Sum will be updated. Sum will be updated. After which again you are within a loop. So again you will go back on top. This is the third time the statement is executing. Third time. Next again I plus plus means I value is going to increment. After I value increments, check the condition. 2 is less than 3. Because it is true, I will come inside. If in case I come inside, this statement is executing for the third time now. So 3. Next what is going to happen is, obviously I will update the sum. So sum is going to become 8. Right? Great. After which again I am within a loop. Right? So I'll go on top. Now watch it. Again I'll go on top. If I go on top, then you must understand this time I plus plus I will do. So I value will increment. And this is the fourth time it is executing. I value will increment. See, from 2 it is going to become 3. So you see this statement, how many times is it executing? This is the fourth time. But the fourth time that it is executing, I value is now 3. If I check the condition, is 3 less than 3? False. So the condition became false. Control will come out of the loop. So control will come out of the loop. Now here's something I want you to understand. Now look at this for statement. How many times did it execute? 4. Look at the statement in the body. How many times did it execute? 3. So why is it that the for statement executed 1 time more than the number of statement in its body? Is because the last time where the termination condition occurs, where this condition fails, that also should be considered. So this will execute only as long as the condition is true. This statement will execute for every time that the condition is true and for the 1 time that the condition is false as well. So if the for is executing 4 times, body will execute 3 times. If this is executing n times, this will all, if this is executing n times, let us assume this is executing n times, this will always execute n plus 1 times because of the termination condition, because of the false condition. I hope you're able to think. Now, so totally this program, if in case my n value, now tell me what is deciding how many times this will execute is this n value. Would you agree? That is what is managing the condition. If n value is 3, then totally you got 1 plus 2 plus 3, 3 plus 4, 7, 7 plus 3, 10. 10 times, 10 operations it is performing. I hope you're able to think. Naturally, if n value was 5, it will increase. If in case n value was 10, it will increase. If in case n value was 100, it will increase. Clearly, it is increasing. But one thing I want you to understand is, this will not give me an estimate of how much time it is taking. I want to represent it mathematically. So what will you do? What I will do is, this, again I told you, these 3 guys really don't matter to me because they are constant. Whatever is the size of the array, whatever is the n value, these guys will execute only once. But that is not the case with these statements. So these 2 statements I would like to represent it in general form. How will you represent it in general form? I would like to correlate it with the n value. How will you correlate it with the n value? N is 3, this is 4. If n was 5, this will be 6. If n was 10, this will be 11. Whatever is the value of n, this will be plus 1. So would you agree? I can write that 4 in general as n plus 1 times. I'm coming below. Look at this. How many times will this execute? If this is executing n plus 1 times, always 1 time lesser. 1 time lesser. So this is 3. 3 is nothing but n. If n is 3, 3 times. If n is 5, 5 times. If n is 10, 10 times. Which means, don't you think, in general I can just write it as n. So did you see how I brought it in general form? Now I know, depending upon the value of n, this will execute n plus 1 times. Depending upon the value of n, this will execute n times. So this is my frequency. Now I'll add all these frequencies together. I will add them together. I'll get 2n plus 1, 2, 3, 4. 2n plus 4. Now, using this value, you can represent the time complexity of this code. How will you represent the time complexity of the code? If you ask me, it's very simple. For that, we will be using a notation called as the big O notation. Now, I want you to forget what big O means. There is big omega, there is theta. I want to forget all of this. Big O will tell you how much time your code is going to take. Now, to represent this as big O, there are 2 conditions you must keep in mind. Condition number 1 is to eliminate constants. Condition number 2 is to only retain the highest order term. Now what do I mean by this? Tell me, what are the constants here, friends? 2 and 4. If I eliminate 2 and 4, what I'll be left out with is n. Now, n is the only term, which means it is the highest order term, right? Order means what? See, I have n. I can have n square. I can have n cube. I can have n to the power 4, lad. I can have n to the power n. Which means highest order means square is higher than n, cube is higher than square, n to the power 4 is higher than cube. But tell me, amongst all these orders, which is the order, that highest order I have here? N. That's the only term I have. So that is what I will have, which means I can represent this as big O of n like this. I hope you're able to think. Any confusion till this point of time? Yes, sir, we perfectly understood. So now you know that this code is going to take n times. Now, n time means what? Depends upon the value of n. If n is 3, it will take some time. If n value increases, time increases. As n value increases, time is going to continuously increase. It is going to linearly increase. I hope you're able to think. In fact, I can just show this to you as well. See here, very simple. Let us assume like this, I have a graph, right? I have a graph. In my graph, this is n value. This is the time. This is the time. I hope you're able to think. Now, naturally, if you look at it, if you understand it, for a certain value of n, there will be a certain time. As n increases, time will increase. As n increases, time will increase. As n increases, time will increase. So do you see that if you have big O of n, this is only nothing but big O of n. Clearly you can see as time or as n value increases, time will also increase. For a certain value of n, there is a certain value of time. For a certain value of n, there is a certain value of time. For a certain value of n, there is a certain value of time. As the n value increases, correspondingly time increases. And how is it increasing? Linearly. I hope you're able to think. So linearly your time of the program, the time the program takes to execute, it will linearly increase. I hope you're able to think. Any confusion till this point of time? Yes sir, we understood this sir clearly. Next, what you may ask. Now, let me tell you what next. So we have analyzed one program. Let us analyze another program which will give you a different time complexity. Watch it and understand carefully. This is the pattern that I have in front of me. Now for this pattern, this is the code. All of you know this code, I am not explaining it. But one thing you can notice about the code is there is a loop. There is a loop inside the loop. There is nesting of loops. And how many loops are being nested? There are two levels, first level, second level. Two levels of nesting has happened. Now, how would I analyze how much time such a code is going to take? Again, you can notice here I have told n. What is this n? This n is nothing but the number of rows. Here I have 3 rows. I could have 5 rows, I could have 15 rows, I could have 500 rows. It doesn't matter, right? Anyways, I want to calculate the frequency because we are using the frequency count method. How will you calculate the frequency of this? Well, all of you know by now. If you have understood the previous program, clearly you know 0 to n means this is going to execute n plus 1 times. That last program only I have conveyed it. But anyways, if you want to understand it once more, I am just showing n is 3, right? That is the first statement that is executing. How many times will it execute if you ask me? See, I value is going to go from 0 to 1 to 2 till here it will be true. Because see, 0, 1, 2. The statements inside will execute for 3 times. But this outer statement will always execute once more because termination condition comes into effect. Termination condition comes into effect. Which means how many times? 4 times. What is n value? 3 times. So 4 is 3 plus 1 or n plus 1. So this executes n plus 1 times. This executes n plus 1 times and I am just showing it there. Now listen to me carefully. This is where either you can complicate your life by thinking mathematically or use this simple trick which I am giving you and utilize this to immediately calculate time complexity in seconds, both while you practice and most importantly when you are attending interviews. What do you mean, sir? You may ask. Simple. This is n plus 1 times. If last program we saw, if the for statement will execute n plus 1 times, everything inside it will execute 1 time lesser or n times, which means this statement n times, this statement n times, this statement n times. That is guaranteed. So just put that. all these statements will execute n times each. So n, n and n. You put it and forget about it. So that's all, sir. Should now I add everything and tell what is the frequency? No, that would be a mistake. Don't do that, because this was only for the analysis of this outer loop, but inside it also there is a loop. Same logic must be applied here. How many times will this work? Obviously, it's going from 0 to n. If it is going from 0 to n, it will always execute n plus 1 times because of the termination condition. And that is what I am also showing here in terms of j. True, true, true. This is for false. Including this, it will execute. So this is 4, this is 3. So n plus 1 times, n plus 1 times. So this is going to execute n plus 1 times. Now the question is, there is already a term here. And now you must attach n plus 1 to it. How will you attach it? Should I put a plus? No. It should always be multiplication. Please remember, it should always be multiplication. So to add another term here, which is n plus 1, I will just write it as n into n plus 1, like this. So watch it. That is what I am showing. Clear till here? Now listen to me. Simple, simple. For is executing n plus 1 times, which means whatever is inside the for will execute 1 time lesser, which means this statement will execute how many times? N times. This will execute n times. So n is already there. Now I want to attach one more n. What is the operator you will put in between? Multiplication. I hope you are able to think. So that is what I am also showing you. This obviously is whatever is inside it, which is nothing but this statement, will execute for a total of n times. So n into n. I hope you are able to think. Then come outside. Now this statement will only execute. This is not inside any loop. This is not inside any loop. This is, it's not inside this for loop. This is inside the outer for loop. And if outer for loop executes n plus 1 times, this will execute n times. This you have already calculated. I hope you are able to think. So no need to do anything for that. That is what I am also showing. No need to do anything for that. Any confusion till here? Now add all of them together. So n plus 1, n square plus n, and this is n into n is n square, n. Remember the two rules to represent it as big O. Step number 1, eliminate constants. Which is the only constant? 1. Eliminate it. I am eliminating 1. This is remaining. Add all of them together. So you will get 2n square plus 3n. That is what I am also showing. Again constants came, eliminate them. I am eliminating them. Now it is only n plus n square. Tell me which is the higher order term, n or n square? N square. Remove the lower order terms, preserve or retain only the highest order term, which is n square. And hence only n square remains. And how are you going to represent this as? Big O of n square. Big O of n square. I hope you are able to think, right? So naturally you can visualize this. Naturally you can visualize this. If this is my graph, friends, if this is my graph, right? Just like previously, this is my n value which is increasing, and this is my time. This is my time. So one thing you can clearly observe here is that it is n square. So n, big O of n was linearly increasing. But when you square it, obviously it will not linearly increase, it will increase much faster. Which means, see, it will increase something like this. It will increase something like this. See, like this, it will suddenly increase. It will not linearly increase, because every time you square 1, then 2, okay, if it is 1, 1 square is 1, 2 square is 4. 4 square is 16, 16 square is 32. I hope you're able to think, right? So, it's squaring, so it'll just increase, like, it'll really increase like this. So, this is how your big O of n square would look like if you were to plot a graph. So, naturally you can see one thing, which is, if in case this is what, let us assume this was big O of n, right? Let us assume this was big O of n. This is big O of n, linearly. So if you notice, let us take some value of n, right? Let us take some value of n. Let me put a different color. Let us take some value of n. If I take some value of n, look at this. This is the time it takes. This is the time it takes. But the same value of n is somewhere here. You can notice. So you can notice, look at the difference in time. Look at the difference in time. N value is same. Look at the time. Whereas look at this time. This is big O of n. This is big O of n square. Do you see the leap in time? Do you see the increase in time? So anyone with common sense, please tell me, is big O of n complexity better or is big O of n square complexity better? Which is better in terms of efficiency? Because I've told you, efficiency is inversely proportional to time. Lesser the time, more efficiency. More the time, lesser the efficiency. So anybody would say, sir, any day big O of n is better than n square. Which means when you're writing code and if you analyze your code to be in n square, you must always try to reduce it. And the ways to reduce it is what you will be learning as a part of your data structures and algorithms course, as a part of all the problems. And naturally, any engineer who has this ability to analyze the time complexity and have tools and methods with him to reduce it is a valuable asset to any software company, to any IT company. So I hope you understand why this is such a sought after skill in any product-based company's interview. I hope you're able to think. Oh yes, absolutely, you are right. What else, sir, you may ask? What else if you ask me? Let us take a look at an n cube complexity. And the easiest way for me to demonstrate n cube complexity is to show you the code where I'm multiplying two matrices, right? Matrix multiplication code. If I show you, 100% you will understand. So let's begin, okay? So this, my dear friends, is the code to multiply two matrices, right? And I'm assuming it is going to be a 3 cross 3 matrix that you're multiplying. And I hope you know how to multiply matrices. So along the row of the first matrix, along the column of the first matrix, you need to multiply every corresponding element and you have to sum all of them together, which is what will form your first element. Anyways, so that is the code that I have here. If you look at it, for loop, inside that another for loop, inside that another for loop. So there is 3 levels of nesting happening. So I'm just going to write this as my code. Now if I calculate the frequency, now it's very straightforward. You can look at it. First I'm starting with the outermost for loop. N is 3. Okay. So what is n? N is basically nothing but the dimensionality of the matrix. So n cross n matrices. So 3 cross 3 matrix is the meaning. Now 0 to n, j is also 0 to n, k is also 0 to n. I hope you're able to think. So watch it. Here I will iterate. So 0, 0, 0, 1, 2, right? But it will not, 3 is for the false condition. So obviously n plus 1 times it will execute, and that is what I am also showing. 4 times, n is 3. So that will be n plus 1 times. And you know, everything inside the body will execute for n times. So see here, n times, this will execute n times, this will execute n times, this will execute n times. So I am just showing you all the statements within the loop is going to now execute for a total of n times. So I'm just going to put n next to it. Great. But you must not stop there. You must come inside. Now there is another loop. So obviously you have to compute for that loop as well. So here also it is going from 0 to n, which means it will execute n plus 1 times, and you can just look at it. If you look at the values of j, it goes from 0 till 3. So this is 4 times. So that is n plus 1. There is already one term. So you have to multiply the new term. So n into n plus 1 times is what it is going to execute. I hope I'm clear. If this is executing n plus 1 times, then obviously everything inside this loop, that is this statement, that is this statement, that is this statement, has to further execute n plus 1 times. Would you agree with me? Which means I must add n plus 1, n plus 1, n plus 1 here. So that is what I am doing. Into n plus 1, into n plus 1, into n plus 1 for all these statements I will do. And that is what I am also showing. I'm sorry, not n plus 1 times, n times, because you know, If the outer loop is executing n plus 1 times, this will execute n times. I hope you're able to think. So n plus 1, so n. Any confusion till this point of time? Yes sir, we understood. Now I'm analyzing this loop. Obviously this loop also will execute n plus 1 times because you can look at the value of k. So n plus 1 times. So into n plus 1. Obviously whatever is inside the kth loop will execute one time lesser. So n times, which means I have to add n to the statements below. So into n I will do. This statement will execute n times. So into n. So these are your frequencies. Now you know how to count the frequencies. Add all of them together. If I add all of them together, I will be getting something that looks like this. N plus 1 plus n square plus n square plus n cube plus n square plus n cube. You know you have to remove constants. So I'll remove this constant, and if I add them, it will become 2n plus 3n square plus 2n cube. I'll remove the constants again, which means it will become n plus n square plus n cube. I will remove all the lower order terms and I will preserve the highest order term, which is n cube, and hence your time complexity is big O of n cube. I think if you have common sense, you know n cube will take more time compared to n square. N square will take more time compared to n. So I hope you're able to visualize that graph. Any confusion till this point of time? Yes sir, we understood. So naturally, if the complexity is n cube, the interviewer will expect you to somehow reduce it. How to reduce it, etc., we will see later. But now we are just computing the time that an algorithm takes. Any confusion till here? Great, wonderful. So I'll just remove all this. Now, all this was very straightforward, guys. It was very straightforward. What if I have a code which looks something like this, wherein for a triangle pattern I have written code, right? And let me just erase this part as well. For triangle pattern, I have written the code. Now, if you look at this code for the triangle pattern, one thing which will be clear to you is that outermost loop is going from 0 to n. But the inner loop, j starts from 0, but it doesn't go till n. It doesn't go till n. Till where is it going? It is going till I. So the same logic which you applied for computing the previous loops cannot be applied here. Same logic cannot be applied here. So how do I analyze a loop where the condition is related to the outer loop? See, I is the outer loop. Inner loop, we are relating it with the outer loop, because as you can see, j means columns. In every column, the number of stars is equal to the number of the row. First row, 1 star. Second row, 2 stars. So j values depends upon I values. And that is the condition. So how do we analyze? So let's begin. I will first begin by analyzing this outermost loop. I will analyze this outermost loop. And outermost loop is going from 0 to n, which means you know this is how it will work. I have for I 0 it will work, for I value 1 it will work, for 2 it will work, for 3 it will work. For 4 also it will work. Now 5 also it will work. I am writing it outside because it is a false value. I am just writing it outside. But n is 5, but I will execute for a total of 6 times. So n plus 1 times. So it's very simple. Here I will just go and write that this will execute for n plus 1 times. N plus 1 times. Now, foolishly, don't think just because the outer loop is executing for n plus 1 times, this inner statement, this statement will execute 1 lesser n times. If you write n here, it will be a big mistake, because that is not how it works. Because this loop's correlation is not with n, it is with I. Which means this would be a big mistake, friends. This would be a big mistake. But at the same time, this statement, which is not inside the j loop, but is directly inside the I loop, obviously this will execute n times. So here I can confidently tell n. Here I can confidently tell n. But for this statement and this statement, I cannot say the same. Why, you may wonder. Look at it. I'm just showing it for you. Now, when I is 0, which means the 0th row, how many stars? 1 star, which means j value technically should go only till 0. Should go only till 0. And that's what, see, 0 less than equal to 0. It will print 1 star. Next time it will become 1. 0 is not less than equal to 1. Hence it will come out and only 1 star will be printed. Correctly it works. Which means this is 0. Okay. But the next time condition failed. For that condition fail also you have to analyze. For this condition failing also you have to analyze. Which means one time extra it will work, and that is why I am just writing plus 1 here. One time extra it will work. I am just writing plus 1. Now for I value 1, 1 means second row. Second row means 2 stars. 2 stars means it will be 0 and it will be 1. Hope everybody is able to think. But the termination condition, false condition also will work. So plus 1. For 2, it will be 0, 1, 2. Plus 1 for termination. For 3, it will be 0, 1, 2, 3. Plus 1 for termination. For 4, it will be 0, 1, 2, 3 and 4. Plus 1 for termination. Of course, for 5 it will not work. 5 means you would have come out of the I loop, so you will never enter inside. So there is no concept of calculating for 5. I hope this makes sense to everyone. Now, I need to calculate the number of times J is executing. If you look at it, all these plus 1s, I will write it as it is. I will just write these plus 1s as they are. But look at this. 0 means how many times? 1 time. 0, 1 means 2 times. 0, 1, 2 means 3 times. 4 times, 5 times. And that is why you can see 1 star, 2 stars, 3 stars, 4 stars, 5 stars. Total number of times, if you want to calculate, you must sum all this up. You must sum all this up, which means I'm just writing it here. You must do 1 plus 2 plus 3 plus 4 plus 5. Plus 1, plus 1, plus 1, plus 1, plus 1. How many plus 1s? 5 ones. 5 ones means 1, 2, 3, 4, 5. 5. So one more additional 5. These are the total number of times that J is looping for. Now you need to generalize it. How will you generalize it? How will you correlate this with N? Very simple. If you look at it, N is 5. What are you doing? 1 plus 2 plus 3 plus 4 plus 5. Don't you think it's the sum of the first 5 natural numbers? Or sum of the first n natural numbers, which means don't you think confidently I can write this as n into n plus 1 divided by 2. This is the formula to calculate the sum of first n natural numbers. I think everybody can correlate. Plus 5, this 5 is same as n. If there were 6 rows, this would be 6. If there were 7 rows, this would be 7. If there were 10 rows, this would be 10. Which means, don't you think confidently I can write it as n? Which means in general, the inner loop is going to execute n into n plus 1 divided by 2 plus n number of times. Not n times. That is, if in case this was n, I would agree, but it is not n. And hence, I will have to go here and write this is nothing but n into n plus 1. N plus 1 divided by 2 plus n. I hope you are able to think, right? Oh, correct, sir. Correct, sir. So, inside this, how many times will it execute? How many times it will execute means you can remove this plus n. This will not work because this plus n came from where? These plus 1s. These plus 1s came from where? The false, the termination conditions. These termination condition executions don't apply for the inner statement. It will execute these many times. This plus n is only for this outer one, which means confidently I can tell if I remove that n, this will be n into n plus 1 divided by 2. I hope you're able to think. Now, if in case I add all of them together, what will I get? This is what I will get if I add all of them together. You know the rule. The rule is you must remove constants. So I'll remove this 1. If I remove this 1, then this will become n square plus 1, 2, 3, 4n. So I'll get 4n plus n square. Would you agree? And that is what I am also just writing here. I will totally get 4n plus n square. 4n plus n square. Again, I don't want constant, so I'll remove that constant, which means I'll get n plus n square. I don't want the lower order term, so I will get n square, and hence this is nothing but big O of n square. So what is the time complexity of your code? N square. Any confusion till here? As you keep solving, as you keep analyzing, just by having one look at the loop and the conditions, you'll be able to immediately predict, oh, this is n square complexity, this is n cube complexity. When further I teach you, you'll see there'll be n log n complexity, there'll be log n complexity, there'll be n plus n complexity. All this you'll be able to instantly identify, but it takes some time. Initially, you must know how to basically break it down and do it. And I hope I've been able to convince you. Big O of n square. Any confusion till here? How we arrived at this is the most crucial part of this discussion. You got a fundamental idea of how these things work. Now we can go ahead and we can be solving more code snippets through which you will be seeing a wide range of time complexities which usually you will be encountering. Anyways, I hope all of you will go practice this and commit it to your memory, because this is a foundational concept if you ever want to master data structures and algorithms. Anyways, let's meet in the part 2 where I will be discussing more code snippets.